Okay, so as I promised you, we're going to finish 1.6 right now with me through this video, so please watch and take notes. Have a notebook next to you just in case I give extra tips or hints or any bonus lessons, or also have this notes out and fill in the blanks, okay? So you guys, we stopped, we more or less stopped here. So I'm going to continue from this example because I want to prove to you guys further on that if you indeed, there's two solutions. If you plug in negative 8 into this and also negative 1 into this, they both make them true. So let's plug it in. 5 times negative 8 minus 2 equals, does it equal 7 times negative 8 plus 14? Let's check, okay? 40, negative 42, that's going to be 42. Does it equal negative 56 plus 14, which is 42? And that's true. All right, how about here? Let's plug in 5 times negative 1 minus 2. Does it equal 7 times negative 1 plus 14? Let's check. 5 times negative 1 is negative 5 minus 7, so 7. Does it equal negative 7 plus 14? 7? And yes, it does. So you guys, they both equal. Therefore, that's why there's two solutions, okay? But obviously for this one's here, we said, remember how we discussed this in class? Before you do any work, always ask yourself, absolute value of something is equal to a negative number? That's not even true. Can't equal negative. Absolute value can't equal negative. Silly, so it's no solution here. Okay, that's why it's no solution. Even when you actually try to solve it and graph it, it won't work, okay? How about here? You know you have to get rid of the 15 first because you have to get this sucker by itself, right? All right, so you go negative 3. Z plus 7 is equal to positive 27, right? Oh, I'm so sorry, negative 3. What am I doing? Okay, negative 3. And you divide by negative 3, absolute value of Z plus 7 is equal to positive 1. And now you separate, because it's all alone. Z plus 7 could equal positive 1, but Z plus 7 could also equal negative 1, because remember, it's distance. There's two different directions. So Z equals negative 6, Z equals negative 8, and here are your solutions. All right, let's go on. Okay, turn the page on your notes. And now you should be looking at this guy here. We sort of did this example in class already, you guys. So if you want to move ahead on the video, you can do so. So here, I'm going to try to get this sucker by himself, so I'm going to get rid of 2 over 3. How do I do that? Multiply by the reciprocal. So I'm going to multiply both sides by 3 over 2, 3 over 2. But remember, you only apply the multiplication once because these are all factors. Remember, factors, okay? So haya, absolute value of 3x minus 6 is equal to haya, and that's 6. Okay? So now, I want to simplify everything first. Is equal to 6x minus 12. Now the absolute value is standing all alone, so I could branch out. 3x minus 6 equals exactly what you see. And 3x minus 6, left hand stays the same, equals negative 6x. Plus 12. These are opposites now. The arrows are important, okay? Now when you solve it, you get x equals 2 and x equals 2. Therefore, this symbol means therefore, x equals 2 is your only solution. That means there's only one value that will make this equation true. All right, can we move on to part 2? Make sure you stop the video at any time if you need assistance, okay? Or you need to slow down. Make sure you try to digest everything before moving on. Part 2 is solving absolute value inequalities. But remember, always check for extraneous solutions. Extra. That means there might be solutions that you actually solve for, but may not work, okay? Solve the inequality and graph. But before you solve anything, you're tempted to solve it right away, but you guys remember, absolute value is greater than a negative number. That's impossible. So you know this is no solution again. Okay? All right? And how about here? You would actually divide by, so you have to get this sucker by himself, right? So you want to divide by negative 2, divide by negative 2. Absolute value of x plus 5 is less than, because you have to flip the inequality since we divided by a negative, it's negative 5. So we know it's going to be, But now look, absolute value is actually less than the negative again. Is less than a negative again? Is less than a negative again? That's not possible. So it's going to be no solution again. Don't even go any further when this happens, okay? Don't go any further. So we're going to actually summarize what we just talked about. So go ahead and flip your notes to the next page. When you have an absolute value of ax plus b, which is greater than a negative, your solution will be all real numbers. Because you know that every absolute value has to be greater than a negative. Because an absolute value will always be greater than a negative, okay? Or greater than a 0, I guess we should say. But now, when absolute value is less than or equal to a negative, then your solution will be no solution, because it's impossible to achieve a negative value when you absolute value something, okay? Because remember, it's always a distance. So let's actually go here. So make sure you keep that in mind, but let's actually solve this. So first step is to isolate the absolute value portion. So you subtract 6 on both sides, right? So you get 5, absolute value of 2r minus 3 is greater than or equal to negative 2. Looking good, but we got to divide by 5. So absolute value of 2r minus 3 is greater than or equal to negative 2 fifths. Before you branch out, ask yourself, is this possible? Of course it's possible. But you guys, absolute value is always greater than or equal to negative 2 fifths, right? Always greater than a negative number. So it's all real numbers. Solution, okay? And even if you actually graph this and solve it all the way, you'll get the same thing. So before you waste your time, you can actually conclude that, okay? All right, let's move on to the next example. And if you have any questions about the video, please come in and ask, okay? About any other thing that you need, any extra support that you need. Let's go to example 4, okay? Solve and then graph. So we're going to first solve like we always solve. So we add 5 to both sides. 2, 4x plus 1 less than or equal to 6, all right? We divide by 2. Absolute value of 4x plus 1 is less than or equal to 3. These steps I didn't show, but make sure you understand them, okay? But also I'm going to give you guys a little, well, let's actually do this first. Well, you know what? I'm going to give you a little pointer here, okay? A little pointer here. Okay, you guys, if absolute value of x plus b is less than, or absolute value of x plus b is less than or equal to, a number k being any constant, then you know, then it's an and graph. Okay? Okay? But if ax plus b is greater than k, or ax plus b is greater than or equal to k, this is what you need to put on your extra notes, on your notes section for 1.6. Then it's an or graph. Okay? So you guys, look at this right here. Is that an and graph or an or graph? If I heard you right, you said and graph. So you should know what to expect. Okay? Look at the next one. See this one? You should know that this one tells you it's an or graph. So know what to expect. Okay? All right. Not yet, maybe. After the, you should actually say when the absolute value is alone. Okay, guys? Just to mention that, just to clarify that. Now erase this part. Okay. Make sure you you rewind the video. All right. Now let's actually solve all the way. So we do it the same way. Once you have the absolute value standing alone, you branch out. But you guys, this side it stays the same. This side though, it's the opposite distance. So it's going to be greater than or equal to negative 3. So you guys look, it changes here and changes here. You guys, this is very important. You guys, make sure you know it's a change here, okay? And then you solve it normally. So you'll get x is less than or equal to half, and you'll get x is greater than or equal to negative 1. Now we're ready to graph. And you guys, let's actually graph what it says. It says negative 1 and a half. It's a closed circle and a closed circle. Greater than negative 1? but it's less than or equal to half. So it's going to be here that we graph. And in our solutions, I would like for you to write like this, x such that negative 1 is less than or equal to x is less than or equal to half. It's an and inequality. And it satisfies what we thought it was going to be, and. Okay? All right. Let's go on to the next one. Subtract 5 on first time, right? So 3z minus 2 is greater than 4. Okay? Separate. If you want to try it and check it back with me, then stop the video right now. 3z minus 2 is greater than 4. 3z minus 2 is less than negative 4. Change, right? Opposite, okay? And you guys, we should expect, now we could actually, at here, at this stage, we could say we should expect an OR graph, okay? So we solve this all the way. We get 3z is greater than 6. So z is greater than 2. Or, plus 2, 3z is less than negative 2. Z is less than negative 2 over 3. Let's graph it. Negative 2/3 is here, open circle. 2 is here, open circle. It's greater than 2. It's less than negative 2/3. It's an OR graph. It's satisfied. OR graph, and it's OR graph. Okay? Make sure you digest that, okay? All right. You guys okay here? I'm going to change the slide. All right. If you're getting bored a little bit, just bear with me. We only have 2 more parts left, okay? All right, so you guys, writing compound inequality. This is the hardest part. This is the hardest part, okay? So this is the part that you might need a lot of the video, okay? Okay, you guys ready? All right, let's do this. Writing compound inequality to an absolute value inequality. Wait, writing compound inequalities to absolute value inequality. So we're going to go back and forth. It says write an absolute value equation or inequality to describe each graph. So look at what you see. Think about it first. Is this an inequality or an equation? Is there a multiple of solutions or just 1 or 2 solutions or no solutions or all real solutions? Looks like there's 1 solution here and 1 solution here. It's 2 solutions, okay? So you guys, this one's actually an easy one. That means if you were to write an absolute value, what value gives you 6? That means x. Because if you actually solve this, try solving it. X could equal 6, x equals negative 6. And those are the 2 solutions. So you're kind of thinking backwards. I know it's a little tricky at first, but you'll get used to it, okay? Let's go to the top here. Let's go to here. Now you can definitely see that this is an inequality. It's an open circle, and it's everything to the left and to the right of this value. It looks like this value is negative 2.5, and this is 2.5. Okay? All right. So you guys, let's look, okay? Is this going to be this? Is it going to be an AND graph or an OR graph? We know it's 5 over 2, but we kind of already know that it's going to be an OR graph, right? Because they're going opposite directions, right? And we established, remember the little tidbit of note that I gave you? We said this right here, this symbol, if it's this or this, if it's greater than or greater than or equal to absolute value x plus b or absolute value x plus b here, then it's going to be an OR graph. Remember that we established that? Take it back on your notes, okay? So we know, look, the 0 is the center, okay? And it's 5 over 2, 5 over to the left, 5 over to the right. So we know our answer is x is greater than 5 over 2. And try solving it, you guys. Branch out. X is greater than 5 over 2. Is that true? Yes. And x is less than, so we flip that, and negative 5 over 2. And is that true? Yes, x is less than negative 5 over 2. Okay? You guys, that's the hard part. This part and the next part is the hardest. Okay, guys? So, okay, bear with me. All right. Now, if you understand that, it should be okay. But you guys also remember this. This is the center. 0 right now is the center. That's why these are equal distant apart, equal distant away. Okay? Keep that in mind, okay? All right. And don't worry, on Friday, I'll give you guys time to work in class. Okay, but make sure you try the homework before coming to class so you understand better. So your book is going to talk about tolerance. And as I wrote, this part is very difficult. Okay? But I hope I can explain to you the best way I know how. Write each inequality as an absolute value inequality, okay? So you guys, we see an inequality right now, okay? And they want us to write an absolute value. So we did it earlier as they gave you a graph and you wrote an inequality. But now we're going to write the absolute value according to the inequality that you see. And your book calls it tolerance, but I'll explain what tolerance is later, okay? But you know what it's like, you guys? This is a little side note, okay? You guys, it's kind of like asking you what number, let's see, what number could be at most 1 below or above 100? Okay? So it's 101 and 99, okay? So think of that logic, okay? So remember, also absolute value is the distance from 0. All right, so you guys, we need this value. So think about it. For what value of A is the distance 7.3? Either way, right? That's what we're asking. So this one's really simple. Absolute value of A has to be less than or equal to 7.3. Okay? So okay, for what value of A, so we're asking here, right? For what value of A is the distance 7.3? So what's this number? This number indicates distance. Remember, absolute value is distance, right? Remember, we kept emphasizing that? Okay? All right. And of course, we're assuming that our middle point or our center or our starting point is 0. And when you actually solve that, you do end up with this. Because remember, we said this less than or equal to or less than absolute value is going to be an and graph, okay? How about here? Now, this one's tricky because these are not equal distant. But I want you to think about it. Find the middle between 28.6 and 29.2. What's the middle of that? Well, if you don't know right on top of your head, you can take the average. Isn't taking the average finding the middle of something? Okay? And when you actually add and divide by 2 to find the average, you actually get 28.9. And the significance of this number is that this number is your new 0. What do we mean by that? And how far is it from this guy and this guy? 28.9, isn't it 0.3 away from this guy? And isn't it 0.3 away from 29.2? So, let's think about this, okay? So that means we have this F. Okay, we'll call it Fahrenheit, okay? We'll call this F, okay? We have this new middle, okay? But we know whatever we do to it, it's going to be within 0.3. Okay, this is the distance. Okay? And you guys, just to prove it to you, I'm actually going to solve this all the way, okay? So we know if we solve it like this, F minus 28.9 is less than or equal to 0.3. F minus 28.9 is greater than or equal to negative 0.3. And when you actually solve that, you get F is less than or equal to 29.2. F is greater than or equal to 28.6. See? And that satisfies that. That means your F is within 28.6 and 29.2. That's what this is asking. Right? What's the value between? So if I tell you, like, to be healthy, Miss Chang has to be within 5 kilograms of her weight of 100, right? So I could be 105, my max weight, or 95, my minimum weight, okay? So I know this could be the most trickiest part, but we can actually work on this in class, okay? So make sure you come with questions. But you guys, your book describes tolerance Okay? Your book's tolerance is actually this distance here, okay? So don't worry about that word too much. But let's take a look at another example. The outdoor temperature range between 37 degrees Fahrenheit and 62 degrees Fahrenheit in 24 hours. Let T represent temperature, and let's write this into an inequality, but as well as a absolute value. So you guys, what does it say? Isn't it saying that your temperature, lowest it could be is 37 degrees, but it has to be between 37 and 62. So writing the inequality is very simple. But what's difficult is writing the absolute value. So we got to think backwards. What was our first step? Remember, first step is to find the middle, find your new zero. First step, find your new zero. And that's how you find that. Remember how you find that? You find the average. What's the average between 37 plus 62? It's going to be 99 over 2. Okay? Or, in this case, 49.5. And your second step is easy. Okay? Remember, they're wondering, how many is this absolute value? Always. You start with your temperature first, always. Okay? And you think about, what's your new center? This is your new center. You're not going from 0 anymore. So you're going to go minus 49.5. Okay? And it's going to be within, now you have to think, how far is this away from 49.5? How far is 37 from 49.5? So we're thinking 62 minus 49.5. 49.5 minus, what am I doing? Oh, sorry. Yeah, 49.5 minus 37. What do you get? And you actually get this value of 12.5. So you guys, when you actually calculate this, can you guys see that? It's actually 12.5. Okay? So this is our final inequality answer. But if you want to prove that it's right, all you have to do is separate it. T minus 49.5 less than or equal to 12.5. T minus 49.5 greater than or equal to negative 12.5. And when you actually solve that, you get T is less than or equal to, what do you think? Yep, you got it, 62. And it's within greater than or equal to 37 degrees. See, it all makes sense, okay? But I mean, if you really don't understand what happened, don't worry, you can always ask me. But also you could know, it's always kind of a formula. You start with your variable, and you have to subtract out the new zero, absolute value. It's always going to be less than or equal to. And then your tolerance or your new, your distance away from your new zero. Okay? You guys, that's the hardest thing that you're going to see on your notes, on your actual homework, okay? But good luck, and please ask me any questions, okay guys? Alright? Bye! Have fun!